Hey, Miss Marion here. What we're going to do today is we're going to do a review for the DWSBA. We're taking the DWSBA tomorrow, so it's district-wide standard-based assessment. The DWSBA is half of Unit 5, so it's part 1 of Unit 5 and a couple questions from Unit 4. So we're going to go ahead. I have the note page. It's actually linked to the Canvas page if you want to go ahead and download that, print it out if you have it. If not, you can kind of take notes on your own piece of paper. But however you want to do this, but please take notes on this so you understand and know how to do this, because these type of questions will be on the DWSBA tomorrow. So make sure you follow this. All right, here is number 1. It says match each system of equations with the number of solutions the system has. Okay, so let's think back to systems and what it actually means. So let's look at A first. Well, actually, let's go ahead and go through some notes for a second. So going back into our notes, and we can look at kind of what we were doing before. So if I had 1/2 x plus 1 equals 1/2 x minus 2. And remember what we did is we looked at these and said, okay, they have the same variables on both sides. But then my numbers are different. So same variables, numbers are different. This was no solution. Okay? You start to remember this again. So then we had, let's say we had 1/2 x plus 2 equals 1/2 x plus 2. Again, let's look at it. We have it where our variables are the same. The numbers are the same, so everything else is the same. So remember, this is infinite, many solutions. It's also known as all real numbers. Okay, let's make that end a little better. Okay, then what if we had it to where it was 1/2 x plus 1 equals 2x plus 3. And so again, let's look at it. Are my variables the same? They are not. They are different, and this would be what is considered one solution. Okay, I'm going to leave all those notes there, and we're going to go ahead and we're going to go through A. And remember, with A, because both equations are solved for y. Again, both equations are solved for y, I can equal them together. I can say -4 over 3x plus 4 equals -4 over 3x minus 1. So now let's start checking it. Are my variables the same? Yes. Are my numbers the same? No. The variables the same, numbers are different. This is no solution. Okay, now let's look at number 2. Both the equations are solved for y. Because both of the equations are solved for y, I can do 4x minus 5 equals -2x plus 7. Now let's look at it. Are my variables the same? They are not. This is one solution. Okay? And so let's go ahead and let's move on to C and D. Let's go ahead and jump down to let's jump down to D for a second. Notice how here I have the distributive property. Let's multiply in our 5. So we're going to say 5 times x is 5x minus 5 times 3 is 15. So we have y equals 5x minus 15. So now I'm going to equal these two equations together. So I have 5x minus 15 equals 5x minus 15. Let's go ahead and check it. Are my variables the same? They are. Are my numbers the same? They are. So our answer is infinite, many solutions. So now let's look at C. So C has all these different things. Are these equations solved for Y? They are not. So what I'm going to do is I'm going to take this top equation and I'm going to put it at the top. And I'm going to write, so we have 2x plus 3y equals 8. And I'm going to solve for Y. I'm going to get Y by himself. So I need to move the positive 2x. So I'm going to subtract the 2x from both sides. And I'm going to get 3y equals 8 minus 2x. And then because 3y and x are multiplying, I'm going to divide everything by 3. So 3 divided by 3 leaves y. 8 divided by 3 is a decimal, so I'm going to just leave it as a fraction for a second. 2 over 3 is also a decimal. I'm going to leave it as a fraction just for a second. Okay? So that is the top equation. I'm going to take the bottom equation. Again, I'm going to take 4x plus 6y equals 17, and I'm going to solve it for y. I need to move the positive 4x. Because it's positive, I'm going to subtract from both sides. I have 6y equals 17 minus 4x. I'm going to divide everything by 6. 6 divided by 6 leaves y. 17 divided by 6 is a decimal, so I'm going to leave it as a fraction. 4 divided by 6 does reduce down. It is a decimal, but that fraction is a fat fraction. It reduces down to being a skinny fraction of 2/3. Now, I'm going to equal these two equations together. So I'm going to kind of put this in the corner. So I'm going to say 8 over 3 minus 2 over 3x equals 17 divided by 6 minus 2 over 3x. Let's start comparing it. Are my variables the same? Ooh, they are. Are my numbers the same? They are not. So what is this answer? No solution. So if you had some issues with this, go back, rewind it, go through it again. You have a question just like this on your DWSBA tomorrow. Let's look at number 2. So it says solve the system of equations. We can equal these together and solve for x and y. Also, what we can do is we can graph these. So I want to show you through graphing how these can also be we can solve it. So remember, the system of equations is where they cross each other. Remember, we have y equals mx plus b. M is our slope. B is our y-intercept, or the y-axis, right? So if we look at this first top equation here, y equals 3x minus 2. Our slope is 3, so our m is slope. In fact, I'm going to write it as slope. So we have slope equals 3, or 3 over 1. And our y-intercept is -2. We're going to start at -2 on the graph. We're going to put a point there. Then we're going to do a slope triangle of 3 over 1. 3 over 1. 3 over 1. And we're going to graph those together. We're going to do the same equation with the bottom one. So here's the bottom equation. Our slope is -2, or -2 over 1. We need it as a fraction. And our y-intercept is +8. So I'm going to go up to +8, put a point. I'm going to do a slope triangle of negative. Remember, a negative slope is where the line goes down the hill. So we're going to do 2 over 1, 2 over 1, 2 over 1. Connect those together. This is where they cross. Now, where they cross is the answer. Where does that cross? So it remembers x, comma, y, or it is side to side, comma, up and down. So our answer is going to be 2, comma, 3. So we can do the same thing with our second one. So let's look at the top equation. So our slope is negative 4 over 3. Y-intercept is positive 4. I'm going to go up to 4, and I need to do down the hill of 4, 3. So I'm going to go 1, 2, 3, 4. So 4, 3, 4, 3. Notice how we connect these together. Same thing on the bottom equation. So my slope is negative 4 over 3. Y-intercept is negative 1. So we're going to go down to negative 1. We're going to do 1, 2, 3, 4. So 4, 3. And if you look at it, it's going to be something like this. These are parallel lines. Are these parallel lines ever going to cross? They are not. So this answer is no solution. Okay. We can also do this algebraically, and where we can equal them together. We can go ahead and find out our x-axis, or our x, and then also find out our y. You can also do it that way too if you want to equal them together and solve for both, if that's okay. So up to you on how we go ahead and do that. All right, let's look at number 3. It says, select all whose functions whose graph include the point 4, 10. The easiest way to go ahead and do this is we're going to put our x, so remember it's x, y. We're going to put these numbers into our equations and see if both sides equal. So what we mean by that is instead of the y, I'm going to put in my 10. Instead of the x, I'm going to put in my 4. So 10 equals 2 times 4. What is 2 times 4? That is 8. So do both sides of this equal? They do not. Is this going to be an answer? No. Let's keep on going. So same thing here. We're going to say 10 equals 1.5 times 4 plus 4. Let's grab our calculator. Let's stick that into our calculator and see if both sides equal. Let's do 1.5 times 4 and then plus 4. This side equals 10. The other side equals 10. Is this is 4, 10 on this equation? Yes, we like it. Woohoo. Let's try this again with the next one. So 10 equals 4 squared and then minus 6. What is 4 squared minus 6? Well, that is 10. So does 10 equal 10? Yes, it does. Yay. Let's try it again. So we're going to say 4 minus negative 6. Put it in your calculator, exactly how it looks with the parentheses around it. What do you get? It's 10. So does our answer equal 10 as far as what we're looking for? Yes, it does. Let's try it again. So we're going to have 5 over 2 multiplied by 4. What is 5 over 2 multiplied by 4? We're looking for 10. It's equal to 10. That is one of them. Let's try 2 over 5 multiplied by 4. 2 over 5 multiplied by 4 is 1 3/5. Does that equal 10 that we're looking for? It does not. That is not one of our questions. Now this one's a little bit different, but we're still going to put our numbers in. So we're going to, and I'm going to change my color. So we're going to have 3 times x, x is 4, minus 2 times y, y is 10, and we want it to equal negative 8. Let's do 3 times 4 minus 2 times 10. What does that equal? It does equal negative 8. So yes, this is an answer. Let's try the last one. Same kind of thing. We're going to say 2 times our x is 4, minus 3 times our y is 10. So we have 2 times 4 minus 3 times 10. That's equal to negative 22. We want it to equal negative 8. Is this an answer? No, it is not. So as far as our answers for this one, all of them we would select are these. And these would be our answers that have the 4, 10 that point includes on those lines. All right, so let's find our slope. So remember, our slope is our vertical over our horizontal. So how does the vertical change over the horizontal change? We are going between 0.4 and 3, so this point, and then 2, 5, this point. So this is our slope triangle. If we look at our vertical, it goes from 3 to 5. So that vertical is 2. Now the horizontal is a little bit different. We're going from, remember this was 0.5 to 2. What is that change? It's 0.5. Let's put it all together as our slope. What was our vertical? Our vertical is 2. Horizontal is 0.5. And we want to divide this out. This is not a good answer. This is not a finished good answer. So let's do 2 divided by 0.5 in our calculators. We're going to get 4 as our slope, or 4 over 1. All right, let's look at number 5. A candle is burning. It starts out at 12 inches long. After 1 hour, it is 10 inches long. After 3 hours, it's 5.5 inches long. Is the height of the candle a function of time, and is it a linear function? So let's kind of go through this. I like to put the information kind of in a table. And so our table is going to have our time that it's burning and the height of what the candle will be. So at time 0, our candle starts at 12 inches long, right? And then after 1 hour, it's 10 inches long. And after 3 hours, it's 5.5 inches long. So let's kind of look at these things and let's see how it kind of changes. So going from 0 to 1, it's adding by 1. Going from 12 to 10, it's going down by 2. And then we kind of have this missing piece, right? Like 2, and then it would be something, right? But let's kind of look at it also. So we went from 1 to 3, it's adding 2. And then we went from 10 to 5.5. So going from 10 to 5.5, it's subtracting 4.5. Okay, so let's kind of just look at the pieces of information. So is the height of the candle a function of time? So for every height, so for every output, do we have exactly 1 input? This answer is yes. Right? Okay, so there can only be, let's spell that correctly. One height for each time. Okay, now let's look at it. Is it linear? So that's where we need to go back to our table. So it's changing by -2 here, but then it's changing by -4.5. Even though we did 2 steps over here, it's changing by -4.5. This was a whole number. This is a decimal. So is it linear? Linear means does it change at the same rate? Or if I graph that on a graph, is it going to make a straight line? The answer is no. This is not linear. And it's because how it changes in our table is not the same change. All right, here is number 6. Wash-A-Lot Car Wash Company charges money for each hour of work plus a one-time fee shown in the table. So we have our table over here, and it says how much does it cost for each hour of work? What is the one-time fee? And I think answering these questions, I like to kind of do them all at the same time. So what I'm going to do is I'm going to look at this graph. And I'm going to go, okay, they went from 1 to 3, so it's kind of like what we did before with the candle. So going here, we're going to add 2. And then 3 to 5 is also adding 2. And then how do we go from 185 to 255? So here it is adding 70. And then here it's 255 to 325. It's also adding 70. Okay, so for every 2 hours, they are adding $70. But we need to do it, so for 2 hours, so it's $70 for every 2 hours. But we want it so it's every hour. Right? So how would we figure that out? We can cross multiply and divide. We can also just kind of divide the top and bottom by 2. So it's going to be $35 for every hour. So how much does he work? So it's $35 per hour. Okay? Now let's come back up here. And now let's say we have to figure out the one-time fee. So after 1 hour, it's $185. We know it goes up by 70. So really, we kind of have to go back on this table and kind of do at 0 hours, what is this fee or the total cost it's going to go ahead and be. So if it's going up by 70, we're going to go down by 70, and it's going to be $115. So the one-time fee is $115, and then they go ahead and pay $35 per hour. All right, let's look at number 7. The graph below shows how much Miss Marion saves money each week. You need to change that on the notes if you're using my note page. And how much money does she save each week? And then what is the initial amount that Miss Marion started with? So let's go ahead and let's figure out. So remember, if we have a graph here, and this is our weeks, and this is the amount of money, what we can do is we can actually figure out like the money per week. And that is through our slope triangle. So we're going to pick 2 points. Doesn't matter which 2 points. I'm going to pick this point, and I'm going to pick, I don't know, we can do this point here. So there are 2 points on the line that's on the grid. It's really easy to go ahead and look at. So we are doing our vertical. So again, we're looking for the slope. It's a change. So how does this line change? And remember, it's our vertical over our horizontal. Let's go ahead and look at these, and let's figure those numbers. So if we are looking at this point starts at 50. This point is, oh, that looks like 40, 45, 50. Oh, so it's 45 to 50. So what is our vertical that's going to be here? Our vertical is going to be 5. You know what? I'm going to put that in black. And then let's do kind of the same thing with our horizontal. Horizontal, oh, it starts at 3, goes to 4. So we have our horizontal, it goes from 3 to 4, so that's going to be 1. Let's put that together. Our vertical was 5. Horizontal is 1. Now let's label it. Vertical, it is money. Horizontal is weeks. So I save $5 for every week. And so, yeah, let's take off the S part because we are good English people. So it's $5 per week. Then what's my initial amount? Oh, let's look at that graph. So that graph, oh, it comes down here. Oh, where does this start? Remember, initial is our starting point. So we're looking for our start, right? And where does that start? I started with $30. All right, let's look at number 8. Kai counts 6 flowers in sunflowers in the yard. He counts then again each for the next 4 days and discovers the number of sunflowers double each day, from 6 to 12, 12 to 24, and so on. Is the number of sunflowers in the yard a function of the number of days? Explain why or not. Is the relationship a function or not? Is it linear? So is this information linear? So what I like to do is I like to go ahead and I like to put everything into a table. I think it's a little bit easier. So we are going to kind of put in our day, and then we're going to put in the number, so number of sunflowers. So let's erase that. So number of sunflowers. Okay, so it says Kai counted 6 sunflowers in the yard. So at day 1, there's 6. And then he again counts for the next 4 days, and he discovers that the sunflowers double each day. Okay, so it goes, so on day 2, it went from 6 to 12. Day 3, it went from 12 to 24. Okay, so we're doubling is what we're doing. So this is our table. We just put it together. Now we're going to go ahead and look at it and go, is the number of sunflowers in the yard a function of the number of days? So really is our output a function of the input? So pretty much for every output, do I only have exactly one input? So day 1, I have 6. Day 2, I have 12. Day 3, I have 12. Is this a function? Yes, it is. And it's because we have a different number of sunflowers each day. All right, so let's go ahead and answer the last one. Is the relationship, function or not, linear? Is this linear? Does it go up by the same amount every single day? That answer is actually no, and it's because it doubles. Does it add by 6 every single day? Does it add by 2 every single day? No, our number doubles. So is this linear? No, and it's because it doubles, not add 2 each day. Also, the other thing that we can do is if we really want to, we can actually take this, we can graph it, and if we put it on a graph, it'll actually show kind of like a curvy line instead of a straight line. But it's because it doubles, it's not just adding 2 every single day. The change, how it changes is not exactly the same, so it is not linear. So this is our review for our DWSBA. Again, make sure you understand and know how to do these questions. If you don't, go back, review it, go back, go through it again, review it, understand it. You do have a DWSBA review in Canvas for you to do. Again, it's going to be the same type of questions on these notes. And then again, the notes and the DWSBA review is going to be just like the DWSBA. You have a test. It is a test. The DWSBA test does go on your grade. It is not retakeable. So please, please, please make sure you understand all of this. Okay? Hope you have a good day. Thanks. Bye.